the last class, we have introduced the concept of object and the class. We have seen that the class essentially consists of all objects having the same structure. That is, objects having the same structure and behavior are grouped into a class. We have seen examples of some classes such as student and a class called triangle. Now we continue in this lecture with the how the objects can be modeled and what are the concepts or the features used in defining the object models. To begin with, therefore, we first distinguish between the class and the object in the sense that whereas class contains objects of having the same structure and a behavior, each object may be thought of as an instance of a class. For instance, for example, a Mary, if you think a Mary as a student, is an instance of the class student. Similarly, we may have another student whose name is John. So, as many instances, there may be many instances of a student in a particular application, and but each one of these students will have the same structure and the behavior. The behavior, as we have noted earlier, is determined by the operations that are supported in the definition of the class. Thus, we had the behavior for the student class. We had seen earlier that that its behavior is defined by the operations such as resides in, has grade, registered into. Similarly, for the class triangle, we have seen that its attributes were vertices and the color, and the operations that were supported are draw, rotate, and move. Whereas an instance, as we have seen, is a typical Mary is therefore any instance of the student will be have on with each instance of the student class such as Mary will be able to perform operations like resides in, has grade, and registered into. So therefore Mary will register into a some course. She will have grade in subjects taken, and she will have an address. And that same thing is true with the instances like John and Lena. Now, if you look at the triangle, for instance, this triangle we have drawn with the coordinate, the vertices 4, 1, 1, 3, and 5, 3 is an instance of triangle. We can color it with a set color like, say, this pink color. If we look at, so therefore this triangle has a color pink, and the coordinates of these triangles are 4, 1, 1, 3, and 5, 3. We can perform operation on this triangle, such as we can move this triangle, we can rotate this triangle. Similarly, we can have a triangle like this with coordinates, say 2, 4, 6, 4, and let's say that is 2 something a like 8, which may not be correct, but so now this triangle again is an instance of the class. So if you denote this triangle as a triangle A, then this is a triangle B, and we can also associate a color with it to which will to complete all the attributes of this triangle. Now, therefore, we can see that in a particular geometric class of geometric objects, there may be many such triangles as are required by the application. So, this is therefore what we should distinguish, that each object which belongs to a class will have an instance, and this instance will be, as we see later on, will be identified by identified which we call object identity. Therefore, each instance of a class will have its unique identity. Now, we cannot take, for instance, Mary, which is an instance of student, will be unique in the sense that there may be two persons having the same name. So therefore, it will be necessary to have an identity so that if there are two Mary in the same instances of a student class, then we should distinguish these two Marys by different, say for instance, an object identity like roll number. So each such instance will have a unique identity, and this identity cannot be changed. This is very important, that it cannot be changed during the lifetime of the object. So whenever, as we'll see later on, whenever we create an object, we should assign a unique identity to that object, and it will remain same throughout the lifetime of the object. Like for example, to illustrate to explain this thing more, for instance, we have created an object with an identity, say 23457 with name Mary, and say the address is say IIT campus, age say 21, course say PGDIT, and subjects taken maybe say object oriented design, let us say DBMS, and so on. And the grade, say with object oriented design, the grade and his or her CGP, or the grade cumulative grade point, say is say 8.6. Now it may so happen during, as the time progresses, so may register into more subjects, and and her CGPA will be changing, or grade point will be changing. However, in each always this number, that is the object identity which we have assigned, will remain unchanged. We may even, if we can delete all these values, yet this number, which is an object identity, will have to remain fixed until an object is destroyed or deleted completely. The object identity will remain fixed. As we'll see later on, this is a feature which distinguishes object-oriented databases from the classical relational databases, where the tuples, the tuples can be deleted, and in that case, that information is totally lost. However, in case of an object-oriented database, until and unless we destroy the object completely, that is, destroy its object ID, the information, the remaining fields of the information can be erased, but yet the object ID will remain uh, unaltered during the lifetime of the object. Now, so therefore, we should differentiate between the class and object, in the sense that classes can be thought of as a sort of collection of all objects, instances or objects which are having the same behavior. And the next thing that we are going to look at is that what is the difference between the class and the type. In programming languages, whenever we look at these programming languages like C or C++, then even Pascal earlier, there was a very strong concept of type. That is, we know that unless the type of a variable matches, it will be any operations with incompatible types will lead you to error, and therefore we cannot assign to a variable, uh, for instance, in C, if say int x, and say let's say int y. Now the assignment of this kind will be treated as an error in C. The reason being, the types of the two variables are different, whereas y is an array, x is an integer variable only. So therefore, there was a very strong the notion of type, and in programming languages, particularly the strongly typed programming languages, the type is often used to check the syntax of the errors, and this also helps in writing correct programs. So therefore, we, all of us who are familiar with the classical programming languages, we have seen that the important role the type plays. Now, in object-oriented languages, on the other hand, or object-oriented languages like C++, as we'll see, the class is in fact plays a very important role, and so therefore naturally the question comes that how should we look at the relationship between class and type. In fact, in many object oriented languages, often class and the types are treated to be synonymous, in the sense that whenever I define a class in C++, as you'll see later, uh, we have defined a variable, we have defined a type, new type, and we can have variables of that type. However, as we have mentioned earlier, a class essentially describes how the objects are internally structured, whereas an abstract data type is also a structure and a model, and with the set of operation. The concept of abstract data type, in fact, came earlier than the usage of the classes in object-oriented languages, and there had been quite a bit of work in the early 70s on the concept of abstract data types. In abstract data types, what we do is that we define the type. Along with the definition of the type, we also define what are the operations that can be performed on the type. Like whenever we say that x is an abstract data type of integer, then there will be operations which are that operations like say plus, multiplication, division, etc. Will be permitted on integer data type. Similarly, if you define a type, say abstract data type called stack, we know that in the operations that are supported on stack are pop, push, etc. We can define an abstract data type called complex number, and again we can define the operations such as plus, multiplication, division, etc. Now, the concept of abstract data type, in fact, can be thought of as something which led us to the definitions of the objects and the class. We have seen that there are certain properties of the classes, and one of its important property of a class is that object is characterized by structure and behavior. So therefore, the operation concept in objects is really something we can think it of along the line of the operation that is supported in an abstract data type. However, as we will see later on, that the abstraction objects require many things more, like the concepts of encapsulation. This concept of encapsulation, however, it was not given due importance in the definition of abstract data type. So although the idea of the type, class and types were somewhat very similar while introducing, there is a subtle difference between the two, and we can really think it of, and a class can be treated as an implementation of a type. So instead of treating class as an abstract, we rather think this is an implementation of the type. Here we clearly say that how this abstract data type is going to be implemented, that what are its attributes are, what are the structures are, what are the functions are, what are the parameters of those functions are, and so on. But aside from this distinction, you will see later on in many programming languages, particularly object-oriented programming languages, there will be very much similarity with the concept of class and the type, in the sense that as we define a class, we can treat the definition of a class as a definition of a new type, in the sense like when we define a class, say student, like this, we will be able to say that that we have a new type called student, and then we can declare variables of this type. This is allowed in C++. You will also see in other programming languages like Java also allow the same. The next concept that we'll have to deal with if I'll deal more modeling objects is that objects cannot remain in isolations. So therefore, if we think everything in terms of objects, so there must be some way that the objects must communicate with each other. So the next topic that we are going to look at is that object communication. Now, we can think it of that suppose we have two objects. Say this is the sender object and the receiver object. What we want, we like to see that when the sender wants to send some message to the receiver, we should be able to define what is the type of this message, what is this message is about, and who is the sender and who is the receiver. In fact, in object-oriented environment, ideally, or the model that we will follow is that each object will send a message to another object, and this message, after receiving the message, the receiver will execute appropriate method. So this is very important. We can we can draw similarity with our existing programming languages. For instance, when we say that we call a particular procedure, now there essentially the calling of a procedure in this environment would be like asking another object to perform the operations or the method associated with the called procedure, and when the calling object, the calling program in this case will be treated as something like a sender. So therefore, in an object-oriented environment, we'll see that with each sender will be associating an object, each receiver will be an object, and they will communicate in terms of messages. And this is one we must remember, that a message, when a receiver receives it, it will execute appropriate method. Therefore, each message will has a name and a number of arguments, including the target object. Here, we will try to identify the number of arguments, and the name will identify that what is the meaning of this message, or what the sender wants the receiver to perform. For instance, if you look at the example of the class, the triangle we had defined earlier. Now, the triangle we had seen that had many methods associated with it, and the methods were the draw, rotate, and move. Question is that suppose another object, say student, wants to draw a triangle or wants to rotate a particular triangle, then it must send a message to an instance of the triangle class to rotate it, and therefore the rotate will have certain parameters with it associated, and then which will identify what is the angle by which it should be rotated, for instance, and which particular triangle is to be rotated. So therefore, that's what we call the target object, and the name of the method is, in this example, will be rotate, and the number of arguments in this case will be only, say for example, the angle by which it should be rotated. So therefore, we can say that the signature of a message or method communication, that is what we will express in this case, is that what is the name of the method to be executed, types of parameters, and the type of object the method returns. Now you can see, as we have mentioned earlier, that whenever the receiver receives an object, it must execute certain method associated with that message. For example, when it receives a message called triangle, an object triangle receives a message called rotate. It must execute a method called rotate, which may be different than rotate, which may have the same name as the message. It must have types of parameters. In this case, the parameters should be that it should rotate by a given angle, say x, where the angle is a definite type, and the type of the object the method returns. In the example considered, the method will return a method object of type triangle, like say the method rotate float angle theta triangle x. It rotates the triangle x by angle theta and returns a rotated triangle. Mind it, here is the in is the is the is an object of type triangle, which is essentially the rotated version of the receiver object, which has been rotated. So therefore, we will get the same as an instance of the object class triangle, which is a rotated version of the original triangle x to which the message was sent. So therefore, to recapitulate, therefore, whenever two objects, say object A wants to communicate with an object B, it has the option that it will send a message, say message is that perform operation X. Now the object B, after receiving this message X, message perform X, what it does, there may be several ways this perform X operation can be executed. And for example, say suppose I have the methods which can be linked together, which can perform these operations are, say, execute x1, execute x2. We'll illustrate with typical examples just now. So now perform X may lead to execution of this method, or it can lead to an execution of this method. So this is a method which is defined, or the operation defined in the class of the object B. Similarly, this is a method, another method. Each one of them is capable of performing the rotation. To take a typical view, typical example in the case, say we have seen that the rotation, say suppose rotate is a method in the class triangle. Now rotate can be implemented in a lots of different ways. For instance, we can say we have a one way of implementing. We can have one C program or C++ one program function rotate 1, and another C++ function say rotate 2. Now both of them are capable of rotating the triangle by a certain angle. Now one has to execute, given the message rotate by the same object A. So object A gives a message A, then it can be implemented either by rotate 1 or rotate 2. This is what we will see later on is related to, so therefore what we are we are saying here that with a message there can be multiple methods can be associated, and we have to resolve which particular method to be executed for in a given case. And this is what is linked with the concept of polymorphism, which we'll elaborate later on. So what we have mentioned just now is that whenever a sender sends a message, it identifies a message by a given name with a set of parameters and the target object onto which it wants that message to be communicated to. The target object, in this example B, on receiving the message, this perform X, has the option of executing different methods, and these methods may be written in different, that may follow different algorithms for implementation. For instance, the rotation of a triangle can be done in several ways in the C program. Or for instance, in another case might be say that we are having a file and you are saying the sorting. So the sorting we know can be performed in a lots of different ways. So if the message is short, so this is, let's take another example to illustrate it. Suppose we have the file as a class. Now this file class is B and we have another class A, and this class A wants that file to be sorted. Now this sort message in a file class, we can say that there can be lots of ways the sorting can be done. For instance, one can have a bubble sort routine, we can have quick sort routine, and so on. To illustrate this concept, so whenever the sort message is sent, we have to some way or other find out or resolve that we can use any one of these and which one to be done in this particular instance. Again, another example would be, suppose we have the class, so let's take the class of B, which contains a geometric object. These are geometric objects which may include this class geometric objects, such as which may include line, it can include triangle, it can include say rectangle, and so on. Now say another class A, say for instance the student class, wants this an instance of the class of geometric object to be rotate. As we can see now, depending upon the what is the type of object the target object is, whether it's a line, triangle, and rectangle, there can be different ways the rotation will be performed, or if the message may be moved. With each of these classes, there will be the move message, so which will move a line, move a triangle or rectangle. So depending upon the type of the class of the target object, appropriate method will have to be executed. And this we'll see that when we have this will be more clear when we introduce the concept of generalization, and where a geometric object will be treated as a generalized object, and line, triangle, and rectangle are the spatial classes of the geometric object, and in each one of them this move method will be available. And when the object A wants to move a particular object of the class geometric object, depending upon the typical instance which we are referring to, the method will be method associated with it. For instance, whether it's a line, then the line movement algorithm or the function will be executed. If it's a triangle, then the movement will be done following the function or operation which moves a triangle, and so on. So this is what, therefore, what we have again the concept of polymorphism, that is, with the same message multiple methods are available, and depending upon the the particular instance on which the operation is to be applied, we have to resolve which specific method is to be executed in this case. So this is one way of, or this is the way we implement the message method communication, and that is how different objects which are present in a particular application will be able to communicate with each other. So the objects may belong to the same classes, both the sender and the receiver object may belong to the same class, or they may belong to the different classes. So to recapitulate, therefore, what we have seen, that we have defined the class, we have defined objects, we have defined class, we have seen that each object is an instance of a class, we have seen that the object communication is with the help of messages and methods. In the usual programming languages environment, often the distinction between message and methods will not be made explicit, excepting there are some languages like Smalltalk which clearly demarcates differentiate between messages and methods. In languages like C++ or Java, we will see that the message and methods are not explicitly demarcated there, but the sender object will explicitly invoke a method of the target object by name only. The next concept that we have to deal with is is related to how do you define the interrelationships among the objects. We can immediately see that objects in a large in a real life environment cannot remain in isolation. So there will often exist a quite a large number of relationships that may hold among the objects or the different types of classes. Now, in order to build a complex object from very primitive objects, we have to define how the simpler objects can be combined to define a more complex object. And these or this the definition of the complex object will therefore incorporate the different types of interrelationships that may hold among the objects. To define before we define the interrelationships is we have to we look at one concept that what is commonly followed in the database literature, what we go by the name called entity relationship diagrams. This approach has been found to be quite useful in the database literature in describing relations among complex entities. So, to draw the parallel with the object-oriented approach, we can think it of an entity is something like an object. So, if you think entity as an object, and the relationships essentially defines how the different objects will be interrelated to one another. And in ER diagram, the entity relationships, are often expressed in terms of the cardinality of the relationships, in the sense, say, let's take an example that we have two entities, one is department, another is employee. So we can think it of department is in class and employee is in a class, and we can say that in a particular department the employees works in a department, and how many employees, it is often expressed in this kind of boxes, and the diamond shaped symbol. These diamond shaped symbols indicate the relationship. So department and employees are related to each other, and this relationship is called work chain. That is, in each department the employees works, and in a particular department there can be more than one employee. So therefore we say that in this case in one department more than one, where n can be greater than or equal to 1. So this is what type of relationships are called 1:n relationships. Sometimes the relationships may be 1:1, like each department can have one manager. So in this case, as you see, we have given, and therefore if you say the department as a class and manager is a class, and they are interrelated in the way that for every department there is a manager, and given each manager is associated with one department only. In this case, each employee will be associated with one department, but a department can have more than one employee. So this is why you call this 1:1 relationships, and similarly, in this case, if we have 1:1 relationships, the relationships can be many to many. For instance, so if you have in relations, this type of relationships will be denoted by, or are denoted in the diagram in this way: m:1. That means that is for with each entity of type of class A, say, will be associated with the many uh, with n number of entities of class B, and similarly an entity of class B will be associated with the m number of entities of class A. Like, for instance, uh, if we look at the previous example, if you say this is an employee and we have here projects, the relationships might be m:1. Why? A particular employee may be associated with more than one project, and a project in a project more than one employee can work in. So therefore, it is neither 1:1 nor 1:n, and we rather we call it m:1 relationship. So this is why these are the typical symbols which are used in the database or literature where to describe or capture the semantics of the data. And this is a very simple model to borrow the same terminology to the object-oriented world. We can think it of each project is a class, an employee is a class, and each one of these two classes are interrelated by this kind of relationships. We will soon see there are different ways of relationships are supported. These are the very simple relationships we have introduced. There are many more types of relationships which the object-oriented approach supports. In fact, these concepts of additional relations that have been introduced in an object-oriented environment are now also being borrowed into the database literature or being used in the database literature to enhance the diagram. And will see later on in this course, when we talk about object-oriented databases, we'll see that we will use this additional abstraction mechanisms supported in the object-oriented model to create more complex database which will conform to the requirement of the real world. So therefore, to conclude our talk of the first lecture, we see that objects, the relationship between the objects and the class is that each class can have more than one object, and in fact all the objects having the similar structures are categorized into classes, and each object in a class will have a unique identity which remains fixed throughout the lifetime of the object. We have seen that how the objects will communicate with each other, and that is by means of the message and the methods, where the sender object will request the receiver object to perform certain operation, and that operation will be executed by and a suitable operation will be executed by the target object when the message is received. It is possible to associate more than one method with a typical one message. However, at the time of execution of the method, it must be resolved which specific method is to be executed, and this idea is linked with the concept of polymorphism to be discussed later. We have also seen that an objects will not exist in isolation, and they may have relationships with each other, and by borrowing from some of the terminologies of the diagram in database literature, we see that the relationships In very simple type of relationships can be 1 is to 1, 1 is to n, or m is to n.